everybody. I hope you enjoyed this quick digital mingle. And for those of you who had any issues, it might be that you need to adjust the settings to allow your browser to use your video and mic. So you have another chance to do this because we will keep this networking tool open all through lunch. So if you enjoyed it, you can continue to mingle then. But we are now heading into our first focused session of the day, and I'm actually going to hand over to today's first guest moderator, and that is Fredrik Lundström, Program Manager at the Swedish Energy Agency. Welcome, Fredrik.
Johanna, it's a pleasure to be here. It was very good to listen to the intro presentations. I think this is a really interesting topic. I work every day in the Swedish Energy Agency, and my role there is mainly in relation to funding of research and innovation projects in the electricity sector. And of course, charging infrastructure and a lot of aspects related to that is an important topic. So I'm happy to be part here moderating this session. We will hear some good input presentations, and the topic is how we can get access to charging in urban areas. As we heard in all the intro presentations there, with the increasing amount of electric vehicles that we see, we will see this, of course, in cities and towns. And how can we make sure that the charging infrastructure is there to support this development and to not create, as someone mentioned, not only range anxiety, but also charging anxiety. And specifically, this is when we look on those that do not have the access to private off-street parking. Many, of course, can maybe have infrastructure at their house using that as a charging solution. But how can we make sure that there is a possibility for everyone to charge that need that, both in terms of the capacity of the grid, but also how we use the space? So from there, we will start the discussion, and we will have about 40 minutes to go in this session. And I will present the speakers soon. I will let the first speaker speak, but just so you have an overview, first we will hear from Cecilia Wemming. Cecilia Wemming is a senior policy advisor at Ellevio, which is one of Sweden's largest DSOs, and she will tell us a bit about cooperation with charge point operators and the municipality to create grid capacity, and how we can do this with the infrastructure that is grid capacity friendly. Then we will hear a bit from Wilkinson, who is the CEO of Urban Electric in the UK. And Urban Electric is building ground-embedded roadside charging integrated with parking infrastructure needed for the mass adoption of electric vehicles in towns and cities across the world. And finally, after Ollie, we will hear a presentation from Turi Kvame Lorentzen, who is a project manager in Beyonder, Norway. Beyonder is a Norwegian battery company that engages in the development and implementation of a more efficient charging station combined with energy storage. So I think this will give us both perspective from different countries and regions, but also on the different changes, both on the infrastructure when it comes to the grid, but also how we use the space and what solutions are available. So let's get started, and I will ask Cecilia Wemming, please, to be welcome to the stage, and we are interested to hear how your work in Ellevio is going on around this topic. Welcome.
Yeah, thank you so much for having me. And we've had some technical issues here in the morning, but we hope everything will work. There's my presentation. Perfect. So, Johanna, you can change to next. There we are. So I work at Ellevio, and Ellevio is one of Sweden's largest grid operators. We own an electricity grid in mid-Sweden, and we're a bit extra proud that we're the grid owners in Stockholm, the capital. And it's about Stockholm that I will talk a little bit today. So Stockholm is, we can change there. Stockholm is a city with very high ambition when it comes to beating climate change. Their goals for the climate is tougher than the rest of Sweden, and by 2030 there should be net zero emission coming from the transportation system. That means electrification is the way forward, and that means high ambition when it comes to charging infrastructure. For the public charging infrastructure, there should be 35,000 charging points by 2030. Now that's a tough goal because today we have around 1,500 to 2,000. So we're far from reaching that goal, and unfortunately the increase per year is too slow. And if that wasn't enough, we have kind of a heavy grid capacity problem in Stockholm. The demand for connecting to the grid will be higher than what the grid can deliver in a few years if we work in the traditional way. Now, this problem will be solved around 2030 when a high voltage cable will be delivered into Stockholm. But in 10 years' time, in exactly the same decade when we're supposed to electrify the whole transportation system in Stockholm, is exactly the same decade that we're having this severe grid capacity problem. So this is a tough nut to crack. So we thought to ourselves, we got to do something new. We can't work in the traditional way. So we can change the, yeah. So we developed a model, we call it Ellevio Smart Charging, in order to kind of make our part in this problem. And this Ellevio Smart Charging got 3 parts to it, as we see it. First of all, we try to be a lot more proactive than we usually are. And we started working closely together with the municipality of Stockholm. And they're great civil servants there that have worked with this issue for a long time. And we kind of joined forces 2-3 years ago. And they have developed something called the charging map, which is the civil servants, they have put up on this map, the charging operators can see where the city allows them to put up public chargers. And from this map, what we did was that we compared this map with our investment plans for Stockholm, because we're investing heavily in Stockholm at the moment. Between 2016 and 2020, we invested 6.9 billion crowns in Stockholm. That means we dig up the streets all the time to replace old cables with new ones. And we thought to ourselves, why not, while we're digging up the streets in reinvestment purposes, why not prepare for public charging infrastructure at the same time? So this type of co-location will save a lot of money and time and, of course, trouble for the Stockholmers, because we don't have to dig up the streets many, many times. First for investment purpose, and then when someone wants to put chargers there. So in order to make this offer, we can go back to, wait, thank you. So in order to make this offer visible to the charging operators, we colored these particular streets where we can co-locate orange. You might see them there. And if a charging operator wants to connect there, the cost from our side will be up to 50% less than or lower than normal. So that's a great offer, we think. Now we can switch to next. The other part, the second part to this Ellevio Smart Charging is that we take a much bigger scope as a grid operator than what's normal. So in Sweden, the charging operator is responsible for the cable connecting the chargers to the grid in the upper picture. That means as a charging operator, you need to dig in the streets, get all the permits, own the cable, and do the maintenance, which is something that a lot of charging operators, they don't have much experience in doing this. It's far from their core business. So what we do now is that we take full responsibility for putting up the chargers in place, which includes owning all the cables. So as a CPO, you just got to come there with your software, basically. So this makes it a lot more easier for the market of charging operators to start a business in Stockholm. They don't have to be experts in digging in the streets here in order to position themselves. They can use us, and this is our core business, and we're very good at it. This is also beneficial for the city of Stockholm, the municipality, because they will get fewer players digging in the streets and owning critical infrastructure. They get more of us, which we hope is a good thing. And third of all is that we have developed together with the national authorities a special tariff for public chargers. the CPOs having this tariff will pay up to it's 30% less than normal connecting to the grid. In exchange, we have the permission to lower the effect on these chargers up to 175 hours per year. Hopefully we won't need those 175 hours, but for us it's a great tool for peak shaving. When the temperature gets very low in the winters, like each 10 winter or something, the temperature will go low, the demand for electricity is high, and the grid will be very pressured. So for us, we can then lower all these public chargers to a minimum for some rare hours per year. But that's a great tool for us in peak shaving, and it makes us able to connect more customers to the grid in that way. So with these three parts, being proactive, working closely together with the city, taking a bigger scope in the business, and this tariff, we think we kind of improve the preconditions for reaching these high goals for public chargers in Stockholm. We don't know, but maybe that's something for later discussions. So thank you so much for having me.
Thank you very much, Cecilia. That was very interesting, and I think it was very clear with these three good takeaways on how you work with making it possible to also handle, as you mentioned, the really challenge with the capacity at the same time that you need to be able to supply this charging infrastructure. Very good. Thank you very much. We will come back with some questions later on. Maybe we will get some insights more to how these problems can be solved already in the coming presentations. I'm happy now to introduce and welcome to all of you Ollie Wilkinson, the CEO of Urban Electric, and from the UK. And Ollie, please welcome to the stage, and I'm curious to hear your presentation.
Thanks, Fredrik. Hello, everybody. Thanks for taking the time to hear about Urban Electric and how we plan to revolutionize electric vehicle adoption in towns and cities across the world. I thought I'd start by introducing you to the team, because I think the key takeaway here is we have around 40 years combined experience in electric vehicles and charging infrastructure. My co-founder, Keith, was responsible for the G-Wiz electric car, some of you may remember, from over a decade ago. And Kvame set up arguably the world's first public charging network, Electromotive and Charge Your Car, which was subsequently acquired by what is now known as BP Pulse. And to visualize that experience, here is a picture that is close to 15 years old now, showing a G-Wiz charging one of Kvame's Electromotive chargers. So to give you some context to explain why we're doing what we're doing, for those of you that may already use an electric vehicle, this statistic will come as no surprise. Nearly all electric vehicle charging today takes place at home, off street, in drives and garages. You know, and for all the talk about charging speeds and battery tech, it is and will always be the fastest way to charge because there is no wait time. You wake up to a full battery, you know, and this convenience has been driving electric vehicle adoption. However, in the UK, for example, you know, a large proportion of households, and this obviously rises in urban areas, do not have access to off-street parking. So unless we find a way for these households to be able to charge conveniently on the street or nearby street where they live, we're unlikely to see an electric vehicle revolution in the places we need it most, and that's our polluted towns and cities. Yet there is growing recognition that cities need to support the transition to electric vehicles. And in London, the mayor has underlined the focus is on reducing the streetscape impact of charge points whilst maintaining accessibility of the pavement for pedestrians. So in light of what is already out there, new solutions are required. Static charging posts, unfortunately, cause street clutter, and they face resistance from residents and city authorities. And this is an issue that will only grow as more and more charge points start to block the streetscape. We love lamppost charging. It's discreet and it leverages existing street furniture, but it is supply constrained due to limited numbers, particularly in residential areas. There may be an unsuitable power supply for EV charging, or they may be positioned on the wrong side of the pavement or sidewalk, so you have a trip hazard with a trailing cable. And in fact, in the UK, for example, a recent study by Brighton City found that only 1/3 of lampposts were suitable for EV charging. So it's a great part of the urban charging mix, but not the full answer. And of course, you've got your DIY options, which would be great for the lawyers and keep them very happy, but clearly this is not a scalable solution. And so at the start of our journey, we spent a good year talking to government, to local authorities, to residents, pedestrians, anyone who would be affected by infrastructure deployment on the street where they live, to really understand their pain points. And we came up with a really simple concept, at least to say, and that's the UE1 retractable charge point that simply hides away when not in use to minimize the impact of charging on the streetscape, meaning we can deploy charge points where others can't. A few things to note about our solution are, it's clearly discreet to preserve the streetscape aesthetics. And keep in mind, our primary use case is overnight residential charging, so minimal clutter or pedestrian impact during the day. It is safe, with obstacle detection to stop lifting children or pushchairs off the ground. It is reliable with high uptime, which is super important, as I'm sure the electric vehicle users on the call will know. But even so, we've designed a unique swap out system, which allows us to replace an entire charging unit within 30 minutes without having to disrupt residents or pedestrians by digging up the road. And actually, here's a picture which demonstrates the system. It's super easy to use via mobile app, just like a parking app, and this means actually it can be integrated into other platforms, e-aggregators. It could be a citywide mobility as a service platform, or it could be a pay for parking app. And importantly, we've seen quite a few innovations in charging where there's a requirement for special cables or some kind of proprietary hardware to operate chargers. But we believe in the one pump fits all philosophy that we've all taken for granted with petrol and diesel vehicles. So our charge point simply works with a standard charging cable that everyone has supplied when they buy an EV. One other very interesting point is actually it's been designed from the ground up, no pun intended, to be inclusive for all, which explains why it rises to the height that it does. There are laws around minimum socket heights, which is 50 centimeters from the ground, but also inclusive mobility guidelines, which is a minimum of 75 centimeters. So there are no obstructions, there's no bending down because it's app operated. It's just easy access for all, regardless of potential mobility restrictions. Last but not least, we are always thinking about the future, and we've allowed room, as you probably saw the box that we showed, to incorporate future innovations. It could be vehicle to grid or even wireless. But keep in mind, the humble socket and cable that we know today will be around for many, many decades to come, because public-facing charging infrastructure needs to work for everyone, no matter how rich or poor or how new or old their EV. So that would include low-income households buying a fifth-hand Tesla Model 3 in 10 or 15 years' time. So any innovations in charging will be an additional feature set to, rather than a replacement of, the familiar charging infrastructure we see today. So to kind of show you our story today, a few years ago, we proved the concept in Oxford City with a single socket retractable charge point. And this was really about, can we build it and deploy it? And yes, we can. And with Innovate UK backing, this is the UK's innovation agency, we're currently demonstrating our technology at greater scale with 108 charging bays across Dundee in Scotland and Plymouth in the south of England. And these images here I'm showing you are from the iconic V&A site in central Dundee. And actually, here's an image just taken hot off the press just last night, just on a typical residential street in Dundee. And you can see the other charge points neatly sort of in the ground because they're not in use. And for the Nordic contingent, of which there are obviously many of you on the call, does it work in snow and ice? I've got to say, we've had our fair share during our pilots in Dundee. So I'm pleased to say it does. And here's a very quick endorsement from a regular user of our charge points, Fraser from Dundee City Council, very much seen as one of the leaders in charging infrastructure in the UK, who says we provide a solution to residential street charging. Thanks, Fraser. And to show the versatility of our solution, here's some images from Plymouth, where you can see we're able to provide a nice, discreet charging infrastructure for the urban residents, whether they live in a terraced house or an apartment. And again, here's another endorsement, why not, from Dan Turner at Plymouth City Council, where he says our solution is to look into the future of our streetscape. So thank you, Dan. We have bold plans to scale our solution across the UK and Europe over the next few years. So please do get in touch if you'd like to know more. Thank you for listening.
Thank you very much, Ollie. I think that was a really interesting and nice example of how to use the space in an efficient way, and very good technology. I think we all, with all the good pictures, we get a good visualization also how it looks. I will immediately, so in order to keep some time left for questions later on, hand over to our next speaker, and here we will hear about another solution. I will invite and welcome Turi, Kvame, Lorentzen to the stage, and we will hear more about how batteries can be a complement and to make charging more efficient, not only on what is charged, but what is charged in your. So please welcome to the stage and go ahead.
Thanks a lot. I'm proud to present Heroes, our EU-funded Horizon 2020 project that started in May and that will last for 3 years. Heroes was set to contribute to solve the great challenge related to the increased market for electric vehicles and the challenge with poor infrastructure for fast and efficient charging in many European countries. So let me see, it's not switching. I'm sorry, the screen is not switching. Sorry. So Heroes is going to contribute to solve this challenge by developing and demonstrating a disruptive hybrid, high-power, high-energy stationary storage system for fast charging of electric vehicles, approximately 20 minutes, to be used in a medium-sized charging station connected to the low-voltage grid. We plan to deploy the storage system end of 2023 in Germany. In the picture, you see an example how we believe the storage station could be installed outside, for instance, a grocery store, so that when you go shopping, the car can be charged in 20 minutes, and when you're back, you can the car is ready to drive again. Other examples could be outside work office places, public parking areas, carpool solutions, or shopping centers, for instance. It should be where people are, so it's efficient in time. To be able to charge many cars within short time, 20 minutes, we need high power and high energy density. Heroes solve this by using lithium-ion capacitor cells developed by Beyonder with high power, illustrated with a cup of water where you see a lot of water coming out at the same time. We combine these cells with commercial available lithium-ion batteries, illustrated that has high energy density, illustrated with a water bottle full of water, but the water is not poured very quickly because of the lithium-ion batteries' lower power. When we combine these two types of batteries, we get a very unique charging solution. Here you see an illustration of the whole system, how we're going to develop the pilot. First, you see the lithium-ion capacitor, and you see the lithium-ion batteries. Each of them have a battery management system controlling the cells and connecting them. And then they are connected to an inverter. The inverter is connected to the local grid. The whole system is managed by an energy management system, that again is connected to a smart controller. The smart controller identifies the energy demand from the local grid. So that, for instance, when there's only one car coming to the charging station, the low voltage grid can, in many cases, be sufficient. But when there are coming a lot of cars, many cars to the charging station to be charged at the same time, the Hero system will provide energy quickly so that all cars can be charged within 20 minutes. Then again, when there is low energy demand from the grid, the lithium-ion capacitor is quickly recharged to be able to support the low voltage grid when there is a new high energy demand from the grid again. There is also an option to connect renewable energy sources to the system, like solar and wind. The benefit from this system is that it enables fast charging of multiple cars from low voltage grid. It also stores energy during off-peak times when low power demand from the grid. It reduces pressure on the grid during peak times, and it utilizes sustainably produced lithium-ion capacity batteries developed by Beyonda that can be charged and recharged quickly within 2 minutes, and long lifetime, 15 years approximately, and low cost per charging cycle. We believe that Hero system will be a key enabler for the widespread fast charging of electric vehicles cost effectively without the need for major investment in the grid, and hence contribute to overcome one of the major bottlenecks for the wide adoption of electrical vehicles. Here you see the partners involved in Heroes, representing the whole value chain from R&D to pilot and testing. Beyonda is the coordinator for the project and responsible for developing the lithium-ion capacitor cells. Ellen Klinger will develop the modules for the lithium-ion capacitor cells. Lithium Balance will develop the battery management system. Siemens, a major technical partner in the project, will develop the energy management system. They will also have the main responsibility for the technical solution. And the pilot will be developed and tested by Bestorage, the company fully owned by EVgo, the third largest energy company supplier in Germany. EAS will be responsible for communication and dissemination, sustainable innovation for exploitation of results and business development, and ENSO for the sustainability part. We believe that the technology has a great potential, that it can be transferred to a number of other areas, including buses, fast charging of buses, boats, ferries, trucks, and even planes. If you'd like to have more information of the project, you can go into our homepage for the project or LinkedIn, or you can contact me and I will provide you with more information. Thanks a lot for listening.
Thank you very much, Turi. That was very interesting to hear. Another very good example of solution. Somehow it made me thinking of how you sometimes buffering in your phone when you're listening to something and you have a bad data transfer, but you can still listening to the program in the rate you want to. And it's a good example of a solution. We will now go on to some questions. So I think we will be able to get the two other presenters up on the stage. Hello, Cecilia. Hello, Ollie. I hope you're still doing good. I will start asking you first a question more in general. We have heard examples now on both how we can have challenges and find solutions for the question of how we use the space in a good way in the urban area, but also how to handle the capacity, both on the grid level, but also how we can find solutions more on the end use level. So if I start with you, Cecilia, how do you look on, from your understanding and from the experience working this far in Ellevio on this, what is the most challenging part? Is it related to the lack of space or the challenge in the grid capacity? or something else?
There are a lot of challenges, I would say. The overall challenge is the grid capacity, of course. We have 10 years going on here that will be tough, and we have to work really smart. But also space. I mean, the grid has to be larger, you know, and that takes place also in the city, like network station and so forth. And space in the city is valuable, and everybody wants it. So it's a lot of negotiation within the municipality to make space for the electric system, I would say. So that's one challenge. But also in Stockholm, it's very expensive to dig in the streets because of regulation that is much tougher than the rest of Sweden. So that makes our connecting to the grid for the CPOs is rather expensive because of that. So we're working with the city in that, with working on that, and they're really looking into that. So that's great. We think we can lower the cost with 30% doing some working on the regulation there.
Okay, thank you. I understand it's a complex matter where these things play together, and you got back also to the coordination with different stakeholders, not at least the municipality. If we have time, I will come back with some question of that. Ollie, you showed us some examples from the UK market. What's your view? I mean, obviously you're working with space optimization, but what do you think about space capacity or other challenges?
I think for us, when it comes to capacity, actually we're, you know, because we're not rapid chargers, you know, we are 7 to 22 kilowatt. We're leveraging the low voltage network. And so for us, capacity is not really an issue. It may become an issue, but it isn't at the moment. So everywhere that we are looking to deploy infrastructure, we've got more than enough capacity to support that growth. So I guess the biggest challenges for us are more around, you know, when you're digging up old streets that have been around for maybe hundreds of years, what you might find. You know, but typically, actually, we have quite a high hit rate in terms of our preferred site location. But so if we choose 10 roads, maybe 2 or 3 of them will fall by the wayside, but we'll be able to have 7 that we can work with, 7 or 8. So, but it is a consideration for us. The other thing, of course, that we should always remember is, particularly in areas of high urban, you know, high density, is, you know, when you have big parking pressures, is being able to get residents on site. So when you're deploying infrastructure, they don't feel like they're losing parking, because it's a very emotive subject, particularly in the UK. You know, can I park on my road or nearby road because there's just so many cars? And so it's important that we can work with the local community to basically tell them that we're trying to help them. You know, we're providing them with a service that will enable them to clean up the air in the areas that they live.
Thanks, Ollie. Very good. Turi, I mean, obviously you have a solution that you described which enables fast charging. Mm-hmm. But how do you see in the bigger picture, and also in relation to space? Does this require a space that is available, and how do you look on this?
Yes, the cities needs to decide or plan where do they want to have charging points, where should they make room for them, and also when they invest and set the criteria for investment, they should emphasize on lifetime and time and cost per cycle rather than just total cost. We also think that like I said in the presentation, the charging stations should be where people are. So make it more efficient, so they don't have to go to a place to charge it, but where people are. And all should have the same opportunity to charge their car, no matter where they live or what type of car they have. Yeah.
Yeah, thanks. I think this is a good segue also, because you also mentioned the role of the municipalities. If I would ask each one of you, I mean, if we want to make sure and ensure that there is enough charging for both residents, taxis, carpools, and all the needs we have in the city, what role do cities, municipalities have in this? I mean, we can always discuss how much responsibility, but if you would think of, if you can only choose one thing, what's the most important things? If it's someone representing a municipality listening, what should I think of? If I start with you, Cecilia.
Yeah, then I would say coordination. Like for us as a grid, as a grid operator working with the transport system and the vehicle operator, it's a new thing for us. And this is new for everybody. And we don't really know how to do this. So we have to grow as we go. And there the municipality can play a big part, I think, to kind of put everybody together. In Stockholm, we created, together with Volkswagen and Scania and the municipality, like an electrification pact that will work for 10 years, inviting everybody that wants to kind of reach these climate goals, working closely together for the upcoming 10 years, just to kind of create a platform where we can collaborate to find new solutions, because that's really
very good.
needed.
Thank you, Cecilia. Ollie, what do you think? If you give one recommendation or one message to representatives from municipalities, what would it be?
I would say, and it's kind of really on the same sort of point of Cecilia, it's that whole collaboration piece. But if I was to say one thing, it's is most municipalities are not set up to run charging networks. And I think in the UK, historically, that's been a bit of a mistake, where the municipality has started to own and operate charging infrastructure, and it hasn't really worked very well in terms of the uptime and availability. And so I think really when it comes to municipalities, it's collaborating with companies that can actually do that job properly. So yeah,
thanks a lot. And Turi, you get one more chance to say something about, if you would send one message to municipalities.
Yes, in addition to what is already said, I think also to believe in new technology and set clear criteria to the need. What, like I said, to time and cost per cycle and lifetime, and facilitate for testing the new technology and support testing of it. And because it's it's a long way. Like Heroes is a 3-year-long project, and it's they need to support this work and believe in new technology and
Thanks a lot. We have little time left, but we received a few questions from the audience also. I will ask you to try to reply quick. I will start off one question that comes from Lars Welling, and it's to Ellevio. Do you use load management sharing in your work?
Yeah, so we're testing a project right now, Meister, and how to steer down the effect from our driftcentral, from where we run the grid, kind of.
Yep.
So it's a really cool thing, and we hope to do that for maybe all the public chargers in Stockholm and in Sweden.
Very good. Then it's a question I think we can direct to everyone. That's from Per Ramstad, and he says charging technology will be provided, as will electric cars. However, are national policies for EV adoption adjusted with national grid capacity down the road? What's your view on this? I start with you this time, Ollie. Do you think, I don't know if this is something you've considered a lot?
Yeah, I think from the UK's perspective, there's definitely thinking there now. There's actually a new fund set up, and this is probably more relevant to your rapid and ultra rapid charging networks, where they appreciate they need to. There's quite a lot of grid reinforcement that needs to happen, and it's very expensive for private operators to do that. So there's definitely moves by the UK government to try and solve that problem.
Okay, very good. And Turi, what's your view? Are national policies for EV adoption adjusted when it comes to the national grid capacity down the road? It's a large question, but maybe you have some insight to
it. Like was mentioned earlier today by Helena, we have a challenge when it comes to fast charging. Like traveling, for instance, and you need the fast charging. But there are, again, I think Heroes could be a good solution there. Allow for a short stop. I think yes, but still, I think the grid is a part of it, so it's a combination. I think we have to look at new technologies, how to solve it, and also looking at how we can combine technology with the grid.
Yeah, thank you very much. Cecilia, you mentioned in the beginning of your presentation, 2030, you will have a new connection that will increase the capacity in Stockholm. But in general, do you think, or do you believe that this is yet enough in the process, moving fast enough when it comes to national grid capacities?
So I don't know if I understood the question really.
Yeah, so do you think that, I mean, we discussed from a point of view of municipalities and others, and in this question, as I understood it, are policies for EV adoption adjusted with the national grid capacity down the road? So when we plan the
no,
grid...
not really. Yeah, but I think it gotta be, and especially when it comes to heavy vehicles. I mean, that's our biggest concern now. The cars are charging them, and that's okay, but the heavy vehicles and supercharging them, that would be tough on the grid, and we have to like have load balancing, and that got to be integrated in the regulation. Especially now in the beginning, if you get subsidies for building charging points, etc., they gotta be charging balancing. Absolutely. If that was
Excellent.
the answer, I don't know.
Yeah, no, that's a good answer. We do have a lot more questions. Unfortunately, we don't have more time, but hopefully the discussion can continue in the breaks or in other forums. With this, I want to thank you all, Cecilia, Olli, and Turi. Thank you very much for very interesting contributions to this topic and to give us some more views on both the challenges and the solutions. And with this, we will close this first session. Next slot of the program will start 11:35, so there will be a break now for almost 10 minutes, a little bit less, but I hope you will get sufficient time to recharge your batteries, and see you at a little bit less than 10 minutes at 11:35. Thank you.